Today our topic is minimization problem in simplex method. What is the procedure to solve this minimization problem in simplex method? Let's see. Here the problem is minimization subject to the constraints to less than or equal to sign. So the criteria for selecting entering variable to pick the variable in objective row, that is called as equation 0 with the most positive coefficient. If all of them are negative or 0, this suggests that the present solution is optimal. So how can we solve the problem with the practical manner? Let's see. The problem is solve the following linear programming problem by simplex method. Minimization of z is equal to 8x1 minus 2x2 subject to the constraints minus 4x1 plus 2x2 less than or equal to 1, 5x1 minus 4x2 less than or equal to 3, and then x1 and x2 should be greater than or equal to 0. Likewise, the problem has the constraint equations. So the first step in simplex method problem solving for minimization problem, inequality constraints converted into equality constraints by introducing slack variable. How? Let's see. Here the first constraint equation minus 4x1 plus 2x2 less than or equal to 1. Likewise the problem has. How can we introduce or convert that inequality equation into equality equation? By the introduction of slack variable. Let's see. Here I introduce the slack variable s1 into the constraint on equation, so that the equation inequality equation may be converted it into minus 4x1 plus 2x2 plus s1 is equal to 1. Likewise, I convert the first constraint equation. After that, I can move to second constraint equation. In that 5x1 minus 4x2 less than or equal to 3 is available. Here I introduce slack variable as s2 with that equation, and then I convert that inequality equation into equality constraint equation. Yes, how? Here you see 5x1 minus 4x2 plus s2 is equal to 3. Likewise, I convert this inequality constraint equation to equality constraint equation with the introduction of slack variable it into the constraint equation 2. And then how can we identify the equation 0, which is objective function? Yes, the problem has minimization of z is equal to 8x1 minus 2x2. After that, I convert that equation with the equality of 0. How can? Yes, z minus 8x1 plus 2x2 is equal to 0, which means the right hand side variables are transferred to left hand side variables, so that I can change the signs as like plus 2 minus, minus 2 plus. Likewise, I convert so that I can get z minus 8x1 plus 2x2 is equal to 0. Likewise, I got the equation 0. Here x1 and x2 always greater than or equal to 0. So for solving this problem with the simplex method, I can always start with the 0th iteration. Here I collect the information and generate the table for solving the problem. In that table there is equation number, basic variable, coefficient of variables, and then right hand side ratio. Likewise, I can frame the table. In that equation number, I have 3 equations in this problem. So 0, 1, 2, I name the equation number cells with respect to available equations with the problem 0, 1, 2. After that, basic variable column according to the objective function equation. Objective function equation is called as equation 0 in simplex method, but in equation 0 there is no basic variable, but I consider the constraint equation 1 means there is s1 slack variable available. This slack variable is also called as basic variable, so that I can pick the s1 as a basic variable cell for equation number 1 and s2 for equation number 2. So likewise, I can pick the basic variable from the constraint equation. After that, I can find the coefficient values from the available 3 equations. Yes, the coefficient of z, coefficient of x1, the coefficient of x2, and the coefficient of s1, the coefficient of s2. Likewise, I can frame the tabular column. Here, if I have x1, x2, x3, x4, x5, likewise means I can I split the table it into n numbers. If I have the n number of variable means I split this table it into n numbers. In this problem, I have only 4 variables which are 5 variables which are z, x1, x2, s1, s2, so that I split the coefficient of table it into 5 terms. Here the first one is z, second x1, third x2, fourth s1 and fifth s2. From this I can collect the variables, coefficient of variables from the equation. For considering the equation 0, the z value has a coefficient of 1, so I place the respective cell as a 1. After that, the equation 0 x1 has minus 8 as a coefficient value, so I place minus 8 for x1 coefficient. After that, x2 has plus 2, so that I place the 2 value in the respective cell. And here equation 0, there is not s1 and s2 value available, so that I can leave with the 0 for s1 and s2. In right hand side there is 0 available, so I can write the 0 value in right hand side cell. After that, I consider the constraint 1 equation. Here minus 4x1 plus 2x2 plus s1 is equal to 1 available. Here I collect the coefficient value of x1. Here x1 has minus 4. In here constraint equation 1 there is no z value, so I am not considering about z value. Here I place as like a 0. For considering x1 there is minus 4 as a coefficient, so that minus 4 I place with the respective cell. After that, x2 has 2 as a coefficient, so that I place 2 in the respective cell. And s1, in this constraint equation there is s1 available, so that I place 1 as a coefficient in s1 coefficient table cell. After that, in constraint equation 1 there is no s2 value, so that I place just 0 in s2 corresponding cell. After that, right hand side there is 1 available, so that I pick the 1 for right hand side cell as a 1. After that, I can complete the first, then I move to second constraint equation. Here the equation is available as like 5x1 minus 4x2 plus s2 is equal to 0, 3. Here I can pick the basic variable as like s2 for equation number 2, and z value there is no z value, and then x1 there is coefficient available for x1 there is 5, so I place the 5 with the corresponding cell, x1 cell. After that, for x2 there is minus 4 available. Here there is no s1 value available, so that I place the coefficient of s1 as a 0, and then in this equation there is s2 available, so I can collect the 1 as a coefficient of s2 and place that corresponding value it into the respective value that is available with the iteration 0th table s2 value as 1, and then this equation has the right hand side value as a 3, so that I place 3. Okay, likewise, first step I can collect the coefficient values from the available equation. According to this problem, there are 3 equations available. One is objective function equation, and another 2 is constraint equation. From this I can collect and frame the table as like this 3 rows and 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. Likewise, I can generate the iteration 0 table. Okay, I can generate the iteration 0 table. What about the next step? The step is started from the identification of key column. Okay, how can I identify the key column? In this table, I consider the first row. From this first row, I can choose the most positive number. Here you see 1, minus 8, 2, 0, 0, 0 available. From this available value, which one is most positive? 2 is the most positive. So that I place here green square box for 2. This corresponding column is named as key column. Likewise, you may identify the key column with respect to the iteration 0th table. After that, how can I find the key row with the available table? Yes, to select the least non-negative ratio and mark that row, the corresponding row is called a key row. So, for identifying the key row, I do calculation for ratio. Here, how can I perform the ratio calculation? Yes, according to equation number 1 row, there is 1 available with RHS column, and then the corresponding key column value is 2. So, RHS divided by coefficient value of corresponding column, so that I can get the ratio as like 1 divided by 2. If I consider the second equation, means there is RHS value is 3 and the corresponding coefficient value is -4. So I can get the ratio value is 3 divided by -4. From this, how can I identify the key row? Yes, to select the least non-negative ratio. Here there are two ratios available. One is 1 by 2, another one is 3 divided by -4. So the second ratio is negative, but the first ratio is positive, so that I can select 1 by 2 as a key row. If I have n number of positive numbers, means I can select the least positive number for selecting the key row. According to this problem, 1 by 2 as the least non-negative number, so that I can choose the equation number 1 as the key row for the problem. From this, the intersection point, the next I can move for identify the intersection. What is the value available intersection point of key row and the key column? Here see the key column and the key row available. In that, the intersection point 2 is available with that intersection point. So the element at the intersection of key column and key row is called key number or pivot number for simplex method problem. What is the next step? Yes, here for solving the problem with the simplex method, the key number is made into 1 by dividing the same row by suitable number. According to this problem, here you see the 2 is available. How can I convert that number into 1? Yes, this 2 can be subdivided by 2. From this I can get 1 in as a key number. So what about other elements that are available with the same table? I also divide all the numbers that are available with the equation number 1, so that -4 divided by 2, 1 by 2, 1 by 2. Likewise, I can perform the calculation with the equation number 1. Yes, I can show you. Here 1, S1, 0, -4, 2, 1, 0, 1 available with the key row. So the key number is 2. Here the key number is made into 1 by dividing the same row by suitable number. I told you how can I convert the 2 by 2 into 1. Yes, divided by 2. Other numbers also divided by the same number, which is 2. So -4 is converted into -2. The 2 is the key number, so 2 can be converted into 1 by 2, and also the last RHS value also converted it into 1 by 2. Likewise, I can change the key number, key column. After that, other elements that are available with the same key column is 2 -4. What can I do? Yes, we can convert these other elements that are available with the key column it into 0. For the reason, how can I convert that? Yes, for example, if I consider the equation 0 row with the respective iteration 0 table, I can pick the values from the table. Here you see I can pick the corresponding values. 1, -8, 2, 0. Key column. Here I converted other elements 1, -8, 2, 0, 0, 0 available. How can I convert the 2 it into 0? Yes, let's see. Here equation 0, 0, 1, -8, 2, 0, 0, 0 available. From key row I can convert this value it into 0. So I always choose the key row for converting the elements that are available with the key column, other elements that are available with the key column. So automatically in key row there is 2 available, so that I can subtract the equation 0 with the key row, means I can automatically get the 0 in the next iteration row. Here you see in equation 0, 2, key row 2, so 2 minus 2 is equal to 0. What about other elements that are available with the same equation? Yes, -8 available, and then in key row is -4 available, so that -8 plus of -4 I can get the -4 After that 0 minus 1 I can get minus 1, and then in RHS 0 available, and in RHS of first equation is 1, so 0 minus 1 is equal to minus 1. Likewise I can get the value for next iteration as a other key column values. After that the equation 2, which is also other element that are available with the key column. Okay, so how can we convert this minus 4 it into 0? Let's see. Yes, the equation 2 has minus 4. In key row there is 2 available. If I multiply the key row value it into 2 means I can get the 4. From this minus 4 plus 4 means I can get the 0. From this I can convert other key element, that is minus 4 it into 0. What about other elements that are available with the equation 2? Here also I can perform the same procedure. For example, in key row for minus 4 I consider, in equation 2 there is 5 available, and in key row there is minus 4 available. According to our equation framing, I multiply this key row value it into 2, so that minus 4 into 2 I got minus 8. After that 5 plus of minus 8 I can get minus 3. Likewise the same rule I follow for solving the other elements that are available with the equation 2 row. And then I consider here 1 is available. After that in key row there is 0, so that 1 plus 0 I can get 1. After that in equation 2 RHS there is 3 available, in key row 1 available, so that I multiply that it into 1 into 2. 1 into 2 I can get 2, so finally I may add 3 plus 2 is equal to 5. Likewise I can get the values, and I can convert other elements that are available key column with the 0. After that I can frame the iteration 1. This table is called as iteration 1th table. Here I can substitute the identified values, and I can remodify this table it into newer one. According to the identified table, in x1, x2, s1, s2 variables does not have any positive variables, all are lying in negative variables. According to our procedure, if all of them are negative or 0, this suggests that the present solution is optimal. So the optimal solution is achieved with the iteration 1th table. How can I choose the optimal value? According to here, how the s1 is changed it into x2? Yes, this question is also available. Here you see the key row has s1, but key column has x2. For this, with this I can convert all the elements that are available with the table. Here s1 is replaced with the x2 because the key column has x2, so that what is the variable that is available with the key column, I convert that with the basic variable that is available with the table. Here you see s1 is replaced with the x2. So in final table, iteration 2 table, x2 is available in the place of s1. So what are the values? Finally I may convert with the same equation calculation. From this I can choose x1 is equal to 0, x2 is equal to what is available 1 by 2, and s2, what is the value available in RHS? There is 5, so s2 is equal to 5. Likewise I can collect the variable values. After that I can substitute the collected values on the mother equation. What is the mother equation? Z is equal to 8x1 minus 2x2. According to this solution of problem, x1 is equal to 0, x2 is equal to 1 by 2. So 8 into 0 minus 2 into 1 by 2. So with this I can get minus 1. So the minimized z value is minus 1 with x1 is equal to 0, x2 is equal to 1 by 2, and s2 is equal to 5. Likewise, we can get the minimized value of the given problem with the simplex method. Thank you all. Now you can understand how can we solve the minimization problem with the simplex method. Thank you all. If you are having any doubts, you may ask me with the comment box. I can explain you.